Alright, and welcome to 2-1 regular versus irregular polygons. So you might be asking yourself, what is a regular polygon? Well, it means that it will have both congruent, use this word congruent here, both congruent sides and angles. So both congruent sides and angles. So what would that look like? Let's take a look at example 1. Here we have this regular pentagon, and it's a regular pentagon because it's going to have all 5 sides are exactly the same, and we know that the angles will all be the same. Remember, when I use one arc for every angle, one arc in each one implies that they are congruent. Now also you might be asking yourself, well, what kind of shape is this? Well, it has 1, 2, 3, 4, 5 sides. So we would actually call this a regular pentagon, where this prefix pent means 5. So a regular pentagon. Okay. Now, for us to answer the following 3 questions, we need to know a couple of things. Thing number 1, we want to find the total number of the interior angles. And how do you do something like that? Well, we have a formula, and we'll use this for every single regular polygon, or every single polygon in general. N minus 2 times 180, where n is the number of sides. So notice, earlier we counted out 1, 2, 3, 4, 5 sides. So I would put in a 5 right there, and then we can say, okay, well, we have 5 minus 2 times 180. And of course 5 minus 2 will give us 3 times 180. And if you use your calculator, you'll find that 180 times 3 is 540 degrees. We would say that the total number of interior angles here is 540 degrees. Now what about the individual interior angles? Well, think about it. If the total is 540, we only have to divide that by the number of angles total, which in this case was 5. And so 540 divided by 5 becomes 108 degrees. So we could actually say, okay, well, this is 108. This is 108. This is 108. That is 108. And that is 108. Now, this brings us to our last thing, an exterior angle. So let me use a different color. What is an exterior angle? Well, that's where we take our line and we extend it here, and we get this angle on the exterior. So let's go ahead and label that. Well, here's the cool thing about exterior angles. They are always going to add up to a total of 360. So all you have to do to find individual exterior angles for regular polygons is to divide them by the number of sides, which, as we know in this case, has always been 5. And so once we do that, we're going to get 360 divided by 5 is 72 degrees. So our exterior angle will be 72 degrees. Now I know that's a lot, so let's go ahead and move on to our second example, and we'll move a whole lot faster this time, I promise. Okay, so for our second example, we have here what we're going to call a regular hexagon. So we have to show that each side is congruent. And remember, I could use 1 tick mark, or if I wanted, I could use 2 tick marks on each side, or even 3. It doesn't matter so long as they're all the same. And recall, every single one of these angles, for it to be regular, must also be the same. Okay, now let's go back to our formula. For our total interior angles, we know that it's going to be n minus 2 times 180. Now here, if you'll notice, how many sides do we have? We have 1, 2, 3, 4, 5, 6 sides. So we're going to do 6 minus 2 times 180. And of course, y'all know this 6 minus 2 will give us 4 times 180. And that is actually going to give us 720 degrees. And if you would like, you can double check my math. If I'm wrong, put it in the comments below. Now for our individual interior angle, remember, we take the total right here, this 720, and we simply divide it by the number of sides that we have. which in this case is 6. Okay, and this is pretty fortunate because 720 divided by 6 is actually 120 degrees. Alright, and so we're saying like every single one of these guys right here is 120, 120, 120, and 120. Lastly, let's go ahead and let's move back to our individual exterior angle. And remember, that angle comes from right here. It's that exterior angle created by extending the lines of the sides of the polygon. And so we can say, okay, for our exterior angle, we know that all exterior angles for any polygon, regular or irregular, will always be 360 divided by the number of sides, which in this case we know to be 6. And of course 360 divided by 6 will give us 60 degrees. Alright? And there is our exterior angle. I hope that this helps as far as regular polygons, but now we actually need to see an example of an irregular polygon. Okay, for example 3, we have this weird shape down here in the bottom right. Now if I were to ask you, are all the sides and are all the angles congruent, you would definitely say no. So this would be an example of an irregular polygon. And let's count out the number of sides. So we've got 1, 2, 3, 4, 5, 6, 7 sides total. 7 sides. Okay, let's see what we can do with that. 1, I'll start with my formula, n minus 2 times 180, and here I know that n is going to be 7. Okay, so we got 7 minus 2 times 180. Now right here we know 7 minus 2, of course that's the easy part. That's going to be 5 times 180. And look, I'm pretty sure that 5 times 180 is 900, but let me go ahead and use my calculator just to be sure. Yeah, and it turns out our total number of interior angles will be 900 degrees. Now our next question is this: can we find the individual interior angles? Check it out. For an irregular polygon, the answer is emphatically no. Because those angles are not evenly divided, we can't just divide by 7. It won't work. What about for letter C? Can we find the individual exterior angles? And once again, the answer is emphatically no. We can only find individual interior and individual exterior when given just a polygon if it's regular. And if it's irregular, we can only work through the total interior angles. Alright? Well, I believe that's it. Oh yeah, the last thing I would say, just for grins, is when it's 7 sides, we call this a heptagon. And this is a shape, 7 means hepta. This is a shape that you're probably a little unfamiliar with. Alright? I'll see y'all in our next lesson.